Good morning, one and all. Good morning, one and all. Today we'll discuss the equation of motion of matter waves. In this, one of the important questions, coding a time-independent wave equation. According to de Broglie, a particle of mass m is always associated with a wave. That means particle is associated with a wave. Particle has wave properties, and wave also have particle properties, and whose wavelength is determined by this. Whose wave length is determined by lambda is equal to h by mv. If the particle has wave properties, it is expected that there should be some sort of wave equation. By using this wave equation, we can describe the particle behavior. For this, consider the system of stationary waves associated with a particle. Let x, y, z be the coordinates of the system, x, y, z be the coordinates of the particle, xi be the displacement of de Broglie waves at any time t. The classical differential equation of the wave motion is given by the first equation, dou square xi by dou t square equals to wave velocity square. In this, the v is introduced. This is the wave velocity. Wave velocity square equals to dou square xi by dou x square, dou square by dou y square, dou by dou z square. X, y, z. We already discussed the coordinates of the particle. Xi. Xi be the wave displacement for the de Broglie waves at any time t. The same differential equation, it can be written as second part. Dou square xi by dou t square is equals to wave velocity square. This is the new term is introduced, that is the Laplacian operator xi, where Laplacian operator is equals to dou square by dou x square, dou square by dou y square, dou square by z square. And the new term wave velocity, we has introduced this, the wave velocity, where xi is a periodic displacement in terms of time. Xi is equals to psi of xyz. Already we have taken xyz be the coordinates of the particle. Xi is equals to psi naught xyz exponential I omega t, where xi is equals to xi naught e power exponential of I minus I omega t. Differentiating the equation with respect to t twice, then we get dou square xi by dou t square is equals to minus omega square xi, where xi is equals to psi naught e power minus I omega t. Now substitute the equation 3 in equation 1. Substitute the equation 3, that is omega square xi is equals to dou square xi by dou t square equals to omega square wave velocity square Laplacian operator square xi. Then we get is omega square xi is equals to wave velocity square Laplacian operator square xi. We know that omega is the amplitude of the frequency, that is 2 pi v, where v frequency of the stationary wave is equals to wave velocity by lambda. Substitute in the equation 2 pi frequency whole square xi is equals to wave velocity square Laplacian operator square xi. Substitute the value frequency is equals to wave velocity by wavelength, that is minus of 2 pi wave velocity by lambda square of xi equals to wave velocity square Laplacian operator square xi whole square, then minus of 4 pi square wave velocity square lambda square xi is equals to wave velocity square Laplacian operator square xi, and multiply cross, that is wave velocity square, both the terms neglecting, then the equation can be written as, in the equation number 4, Laplacian operator square plus 4 pi square by lambda square xi. We already know in the starting, every particle is associated with a wave. Particle has a wave properties whose wavelength is given by lambda is equals to h by mv. Substitute in the equation 4, then it can be written as then Laplacian operator square plus 4 pi square by h square m square v square xi equals to 0. In the equation first one, the term Laplacian operator square, you already know, xi we have given, but the new term we got is m square and v square. Consider if total energy of the particle is E and k is the kinetic energy of the particle and v is the potential of the particle. total energy, if you want to get the kinetic energy of the particle, that is total energy minus potential energy. Kinetic energy is equals to E minus V. Multiplying both sides by m, then the same equation can be written as m square v square is equals to 2m into E minus V. Substitute the equation 7 in equation 6. Then we get is Laplacian operator square 4 pi square by h square into 2m into E minus V. Then after substitution, then the Laplacian operator square, then Laplacian operator square 8 pi square m, 8 pi square by m into E is the total energy, V is the potential energy of psi equals to 0. Equation 8 is the Schrodinger time independent wave equation in 3 dimension, because Laplacian operator square equals to dou square by dou x square plus dou square by dou y square plus dou square by dou z square. Now we already know h Planck or h cross is equal to h by 2 pi. At the same, it can be written as 1 by h cross is equals to 2 pi by h. That equals to 1 by h cross whole square is equal to 4 pi by 4 pi by 4 pi square by h square. That is equation 9. Substitute equation number 9. 1 by h Planck square equals to 4 pi by h square in the equation 8. Then we can get is Laplacian operator square 2m by h Planck square into E minus V of psi equals to 0. That is equation 8 can be written as Laplacian operator square 2 into 4 pi square h square into m into E minus V of psi. 4 pi by h square is 2m by h Planck square, 1 by h Planck square, 2m by h Planck square, E minus V. The equation number 8 and equation number 10, both the equation is Schrodinger time independent wave equation for 3 dimension, because x, y, z we have taken the coordinates. The same equation number 10 can be written as Schrodinger time independent wave equation in 1 dimension is dou square psi by dou x square, dou square psi by dou x square plus 2m by h Planck square E minus V of psi equals to 0. The equation number 11 is for 1 dimension and equation 10 for 3 dimension.